Hey everyone, my name is Addison Rivera, and this is my biochemistry semester project on recombinant DNA technology. So, what is recombinant DNA technology? Recombinant DNA technology is the joining of two different DNA molecules that will combine and be inserted into a host organism, creating a new genetic combination. Some practical examples of this is the creation of pharmaceutical drugs and vaccines, creation of genetic engineered organisms, and gene therapy. Let's focus on recombinant DNA and pharmaceuticals real quick. So, what is insulin? Insulin is an anabolic hormone that is produced in the beta cells of the pancreas, whose function is to regulate blood glucose levels. When blood glucose levels rise, the beta cells in the pancreas release insulin, returning the blood glucose levels to normal. Insulin consists of 51 amino acids and is a dipeptide that is linked by disulfide bonds. The A chain is made of 21 amino acids and the B chain is made of 30 amino acids. The image shows the A chain at the top and is connected to the B chain on the bottom by the two disulfide bonds. So, why do we need to create synthetic insulin if our body already makes it? Well, there is a genetic disease called diabetes mellitus. Diabetes mellitus is when there is a high level of glucose in the blood because there is an insufficient amount of insulin. This can lead to fatigue, irritability, blurred vision, and unexplained weight loss. The treatment for this is injection of synthetic insulin. To create the synthetic insulin, DNA cloning and recombinant DNA technology is used. DNA cloning begins with the finding of the gene we want to focus on. For our case, it is the human insulin gene. We then cut human insulin gene using the restriction endonucleases EcoR1. This restriction endonuclease organizes the palindromic sequence GAA-TTC and cleaves after the GA, creating a 5' overhanging sticky end. We then use the same restriction endonuclease to cut the PBR322 plasmid, also creating a 5' overhang sticky end. The sticky ends then interact by forming hydrogen bonds with one another, inserting the gene of interest into the plasmid. Then the DNA ligase is used to seal the gene into the plasmid. This is now called recombinant DNA. We then insert the recombinant DNA into E. coli using the bacterial transformation. E. coli is then cultured, but not all of the E. coli will take the plasmid, so we use selectable markers like antibiotic resistance to determine if the plasmid was inserted correctly. We then isolate the E. coli who took the plasmid and place it into fermentation tanks where the bacteria will produce insulin, which will ultimately harvest and purify, creating synthetic insulin. So, taking a step back, let's look at DNA technology and its ethical issues as a whole. The first one is, what is preventing us from using recombinant DNA technology to self-improve? The next one is, who determines who can receive DNA changes? And the final one is, should companies and the government be allowed to genetic fingerprint everyone? So, what is preventing us from using recombinant DNA technology to self-improve? Recombinant DNA technology allows us to genetically modify our makeup, so in theory, we can make ourselves be whatever we want. We could change what we think our imperfections are, so we could create a quote, perfect self. We could make ourselves smarter, better looking, more athletic. According to the Catholic Church, all of our skills and intellect is God given. And with these skills, we have a duty to relieve the suffering of ourselves and others. Also, the facilities created by the church, whether it be the church itself, schools, hospitals, and more, are made solely to help others who are less fortunate. So this can be interpreted as We are using the skills God has given us to better ourselves and the people around us, but the counter argument is we are playing God by doing this. God created us in His image, and by changing this, we are going against His likeness and His plan for us. So, who determines who can receive DNA changes? An example that is commonly used is, what if we were to take a baby's genome when they were born and determine that there is a genetic disorder or disease found? Is it ethical to fix the genetic disease or disorder? Could changing the genome of the baby cause more genetic disorders like the creation of cancer, or if there will be any possible long-term effects? So many may argue that we are supposed to look after each other. If we are able to help those suffering, then we should. Jesus healed the sick, and as Christians, we should try to heal the sick. The counter argument is that life is created at the moment of conception. We should not interfere with what God has created. Also, this technology is very expensive. So as a Christian, it goes against our belief of justice because with it being so expensive, will it only be available to the wealthy? Using DNA technology, should the government or private companies be allowed to genetic fingerprint everyone? The argument for allowing the government and companies to genetically fingerprint us is that if there was a crime scene or a major event happened, we could use that genetic fingerprint to track down who exactly was present and when the event occurred, and there when the event occurred. A counter argument for this is an invasion of privacy. Also, with the Human Genome Project, how could we stop companies from discriminating against certain people? For example, insurance companies. If someone were to be found containing a certain health disease, the insurance company might not want to offer health insurance to that individual. And prior to doing this project, I completely supported this argument because if you did nothing wrong, then why would you want to hide yourself? But I never thoroughly thought about the counter argument. I never thought it could lead to discrimination. And because of this, I'm unsure where I stand. With advancements in technology and changing in times, it is becoming easier and easier to take the easy way out. DNA modification is allowing people to mask their imperfections rather than embrace them. It is important to remember we are made in the image and likeness of God, so we should embrace our flaws because those help define who we are. We need to stop worrying about what others think and be ourselves. Be human.